Welcome to the deep dive. Today we're getting into something called agentic AI.
Mm-hmm.
If you think of the AI we usually talk about, it's often like a tool. It does what you tell it, maybe like a really smart calculator.
Right. Very reactive, following instructions.
Exactly. But agentic AI, well, it's a bit different. It's more like giving the AI a goal, say, uh, find the best delivery routes,
Hmm.
and then it figures out the how itself proactively.
Yeah, it adapts. It can choose different ways to do things, use different tools, maybe. It's that step from just reacting to actually acting towards a goal.
And that shift, that potential for AI to be proactive, could really shake things up across loads of industries.
Absolutely. Traditional AI is often stuck in its box,
Yeah.
fixed rules, fixed tools. Agentic AI has this element of autonomy. It learns, it picks methods, it can even improve itself. That's the big leap.
So for this deep dive, we've got some really cool examples of where this is actually happening now. We're going to look at how it's used to gauge customer feelings in actual shops in real time.
In physical spaces.
Yeah. And then how it's helping speed up cancer diagnosis in nuclear medicine, which is super specialized.
And the third piece is fascinating, too, these sort of digital employees popping up. AI experts trained for specific jobs, like in banking or telecoms, to really boost customer experience.
Right. So we're looking at insights from folks like Evident and Infuse.io on the retail side,
Telix Pharmaceuticals for the medical application.
and then Amdocs and RBC talking about those digital domain expert agents.
Exactly. So the mission here is really to unpack these examples. What's driving this? How's it being built? And what does it actually mean, in the real world? Get a clear picture of this agentic shift.
Okay, let's dive right in then. The retail space. Evident and Infuse.io. Using AI in physical stores. Sounds like cameras watching shoppers to see how they're feeling.
Well, yeah, but it's cleverer than just watching. The really neat part is they're doing the sentiment analysis right there in the store. On the edge, as they say.
On the edge. Meaning not sending everything back to some massive data center.
Precisely. They're using cameras, yes, but connected to these Nvidia Jetson devices. Small, powerful computers. And these are running vision transformers, VITs.
VITs. Like AI eyes.
Yeah.
Helping it see patterns.
Kind of, yeah. They help the AI focus on important visual features like we do, and they use the Nvidia DeepStream SDK that's a toolkit for efficiently handling all that video data in real time. So it lets them analyze things like gestures, body language, to get a sense of customer sentiment almost instantly.
So it's not just counting people. It's trying to figure out if they look, I don't know, interested, confused, maybe frustrated.
That's the idea. And crucially, they stress the privacy angle. Only anonymized metadata, like aggregated sentiment trends, get sent to the cloud. No personally identifiable
The
stuff.
subordinate.
Very. And this real-time understanding then powers these agentic things, like AI-driven ads in the store.
Meaning the ads on screens could change based on who's nearby and how they seem to be reacting.
Exactly. If you pause and look interested in something, maybe the display shows a special offer or more info. It's moving from just broadcasting ads to actually interacting.
Making the environment responsive.
Right. And potentially boosting sales, making it feel more personal. The other bit is this context-aware adaptive engagement, using generative AI, the type that creates stuff, and reinforcement learning.
Learning from what works.
Yeah. To tailor promotions or recommendations based on that real-time behavior. You might see a personalized discount pop up nearby. Or maybe a store associate gets a quiet alert if someone looks like they need help.
That can make shopping feel, well, less anonymous. More intended to. What are some concrete examples they mentioned? How's it actually deployed?
They talked about sentiment agents doing that gesture analysis, dynamic storefronts where the digital displays change content, smart displays alerting staff, even AI tweaking things like discounts or background music in certain store zones based on the vibe.
Wow, the store itself becomes sort of aware.
Pretty much. It's becoming more attuned to the people inside it.
So what's the tech stack making this edge analysis happen? Sounds complex.
It is quite a setup. They mentioned custom DeepStream 7.0 pipelines using a platform called SavantAI.io, plus Kafka Connect for streaming the data efficiently.
All right.
Then the core NVIDIA DeepStream SDK for the heavy video processing, and something they called an AI NVR, an AI network video recorder, that takes the camera feeds and does object detection. and also VST, the video storage toolkit, with NV for managing the video itself. It's a whole pipeline.
Right, a lot of pieces working together. How do they actually get this running in a store? Is it a long process?
It seems phased. They might start developing remotely on the Jetson devices using maybe older DeepStream versions. Then they bring in Savant AI.io for more advanced stuff. And the final step is deploying it on-premise in the store itself, using Nvidia NIM to run the AI models and LangGraph agents or bots to manage how the different AI agents work together.
You mentioned agent graphs. What are those exactly? Sounds like AI teamwork.
That's a good way to put it. It's about different AI bits collaborating. They use foundational models. They mentioned Meta's Llama 3, the big 70 billion parameter one for tasks like understanding the store's 3D layout or even generating those dynamic ads.
Ah,
The key is the communication between agents. Some running right near the cameras, the far edge, others maybe on a local server in the store, the near edge, and then the overall privacy and monitoring is handled up in the cloud.
so like a little team of specialist AIs in the store talking to each other.
You got it. Coordinating to create that smoother, more personalized experience.
Okay, so key takeaways from this retail example. It's versatile computer vision.
Yep. Agentic decision-making happening right there.
The hybrid cloud thing, train big models in the cloud, make fast decisions locally.
And those strong privacy guarantees. Really important.
Definitely. Okay, let's switch gears. Healthcare. Telix Pharmaceuticals. Agentic AI in nuclear medicine for cancer diagnosis. And this zero-code idea sounds intriguing.
Yeah, the Telix work is fascinating because they're trying to make AI development much more accessible in a very specialized field. Their platform has two main parts. One is a clinical decision support system, or CDSS. Think of it as a way to quickly build apps for specific cancer types.
Right.
And the other is the AutoML part, automated machine learning. This lets medical experts build AI models without needing to write code. Zero code AI.
That sounds like a game changer for doctors or researchers who aren't AI programmers.
It really could be. Democratizing AI in these complex areas could seriously speed things up, getting useful diagnostic tools developed and out there faster.
So how does this zero-code approach work for cancer diagnosis using PT-CT scans?
Well, they showed a proof of concept for prostate, breast, and lung cancer. They use a specific tracer, 68JA PSMA11. It's marketed as Illuccix with PT-CT imaging. The AI looks at these scans and pulls out some really useful info for the clinicians.
And what kind of info? What's the output?
It predicts the Gleason score for prostate cancer. That's a key measure of aggressiveness and gives a confidence level too.
Okay, that's useful.
It also creates these lesion risk probability maps, basically heat maps highlighting suspicious areas on the scan. And importantly, it generates quality control reports, checks the data integrity, reports the AI's confidence in its own analysis.
It's not just a black box spitting out an answer. It gives context on reliability.
Exactly. Crucial in medicine.
What AI techniques are powering this?
Hmm.
Under the hood.
They're using a mix of things. Deep learning, which is great for visual patterns, is used to outline the prostate gland accurately on the images. For finding potential lesions, they combine radiomics.
Radiomics, what's that?
It's about extracting quantitative features from medical images, textures, shapes, intensity patterns, things the human eye might miss. They combine that with deep learning. Then the AutoML component enables that zero-code model training.
Right.
They also use ensemble learning, combining predictions from multiple models for better accuracy, and something called superlearners, which is like a smart way to stack different algorithms. And to make sure it's all robust, they use 100-fold cross-validation. Really rigorous testing.
Sounds very thorough. She also mentioned GMLP.
Yeah, GMLP, good machine learning practice. It's a framework they use for automatically tracking and monitoring everything during development. Performance, scoring, the whole process. It gives them traceability, which is vital in regulated fields like healthcare. Plus, it helps keep things consistent when using that zero-code approach.
So how well did it actually perform? Do we have numbers?
Yes.
Oh.
For the prostate cancer CDSS, they shared results. Trained on 50 scans, tested on 24. They got 88% sensitivity, catching 88% of the cancers, and 82% specificity, correctly identifying 82% of the non-cancer cases. The AUC, a measure of overall performance, was 0.89. That's pretty strong.
Wow.
They even listed the top 5 radiomic features that helped most in predicting the Gleason score. So yeah, these results suggest this approach could really help develop important diagnostic tools faster and maybe ease the load on specialists.
Really impressive. AutoML genuinely opening doors there.
Seems like it. Lowering the barrier significantly.
Okay, let's pivot again. Customer experience. Amdocs and RBC exploring these digital employees, domain experts. It sounds like a step beyond the usual chatbots.
Oh, definitely. That's the trend. Moving from general AI assistants, sometimes called co-pilots, towards these vertical agents or even autopilot agents.
Vertical agent, meaning specialized.
Exactly. AI systems trained deeply in one specific industry, like telecoms or banking, not generalists. The idea is to capture the know-how of the best human experts and build it into these AI agents for more consistent, high-quality service.
So instead of an AI that knows a little about everything, you get one that knows a lot about, say, phone billing plans or bank fraud procedures.
Precisely. Amdocs is big in the telco space. They're building agents for things like handling complex billing questions, understanding customer history, exploring network issues, even doing sales through conversation and tracking orders.
And RBC.
RBC is looking at digital humans for specific banking tasks. A different approach, more visual.
Building these specialists must be tough, though. What are the big challenges?
There are quite a few. You've got complex workflows, often with many steps. The need for really deep, specific knowledge of that industry. Its jargon, its processes, making it cost-effective is always a factor. Then there's personalization, making it feel like your bank or phone company matching the brand voice. Security is huge, obviously, making sure the AI plays nice with all the existing IT systems, and then keeping them updated and scaling them up. It's a lot to juggle.
That is a long list.
Yeah.
So how are they actually building these verticalized agents? What's the process?
Amdocs described their approach as verticalizing. It starts with basically extracting the intelligence from their top human employees
How do they do that?
by analyzing what customers typically ask for the intents, the functions the agents perform to solve problems, how they reason through tricky situations, and what they call five-star behavior, what makes a customer really happy.
So trying to bottle the secret sauce of their best people.
Kind of, yeah. They take all that captured intelligence and use it to train the AI agents. These agents then deliver personalized interactions, running on a flexible architecture that handles routing, lets multiple agents collaborate, uses LLMOps, that's managing the language models, and relies on a detailed map of the industry in ontology.
So they learn from successful human interactions,
Yeah.
looking at call transcripts and things.
Exactly.
Yeah.
They analyze calls to find root causes of common problems, like in telecoms, maybe it's bills being higher than expected or changes not showing up. They train the AI on these frequent, often complex scenarios.
And this five-star agent idea, what's that about?
It's about identifying what the best human agents do. Maybe they're better at upselling, or they get higher satisfaction scores and building those successful behaviors into the digital agents' interactions. They even look at metrics like how long human agents stay, care-to-sales conversion rates, call center turnover, to figure out the potential impact.
Sounds like Amdocs has a clear plan for these telco Gen AI agents. What improvements are they aiming for? Like real numbers.
Pretty ambitious goals. They want to cut down handling time significantly, deflect more calls away from humans, boost their Net Promoter Score, or NPS, reduce customer churn, improve sales conversion rates, and increase customer lifetime value, CLV, across billing, sales, marketing, network support, the whole lot.
And they're thinking about how these agents work together. Multi-agent patterns.
Yes. They mentioned one called the Collaborative Supervisor Team Hierarchy. Picture this. A manager AI routes the query. A human agent is there to jump in if it gets really complex or needs empathy. And then you have specialized domain expert AIs doing the heavy lifting for specific problems.
A layered approach. Makes sense.
It allows for efficiency but keeps a human in the loop when needed.
And the telco ontology and thinking models you mentioned, making the agents smarter.
Right. The ontology is like a detailed knowledge graph of the telecom world, terms, concepts, relationships. It helps the AI reason better, make connections, and talk to different back-end systems smoothly. Thinking models are strategies to handle those long, complicated customer journeys, optimizing how agents collaborate, maybe fetching needed data earlier to speed things up.
Okay.
And they use NEMO-based LLM-ups for continuously improving these agents, keeping them upskilled.
It's really getting into the weeds, technically. Have they seen results yet?
They reported some positive technical KPIs, lower token consumption, which means lower running costs, better accuracy because of that deep domain knowledge, and faster response times for queries, so customers get answers quicker.
Okay, promising. Now, RBC and their branch, Support 3.0, digital humans. That sounds different, more visual.
It is. RBC is exploring digital humans, but they're also, very aware they're a bank, highly regulated, so they're balancing innovation and risk carefully.
It makes sense.
They see potential uses beyond just fraud, operational efficiency, better customer engagement, but they started with fraud tasks.
Why fraud specifically?
Well, the huge financial costs, obviously, they cited $442 billion lost globally in 2023, but also the emotional impact. Fraud victims feel grief, shame, fear. It really hits hard, so providing better support in that sensitive area seemed critical.
That's a really good point. It's a high-stress situation.
Right.
So tell me about Jessica, their digital human for fraud guidance.
Jessica was designed as an upgrade to an existing tool their advisors used, a kind of fraud wizard. They wanted more agentic smarts, seamless connection to RBC systems, consistency with human advisor workflows, and, importantly, built-in guardrails for safety and compliance. And they built it as a platform that could maybe handle other things later.
What's the tech behind Jessica? How does she come alive?
It's built on the Nvidia Digital Human Blueprint that includes a large language model agent, probably Llama 3 for the conversational smarts, Riva's speech-to-text to understand what's said,
Hmm.
Audio Two-Face to animate Jessica's 3D avatar realistically as she speaks, plus Nemo guardrails to keep the conversation safe and on track, and an agent toolkit so Jessica can pick the right internal tools to answer questions or guide the user.
So it's the whole package. Understanding speech, thinking, responding, and animating the avatar.
Exactly. The Gen AI agentic workflow manages that whole flow, deciding which tools to use, controlling the conversation. There's the speech pipeline, and then the avatar rendering pipeline, making her look and sound natural.
Have they seen results in branches yet?
Yeah, they shared some encouraging early field results. A reduction in average handling time for fraud issues, an improvement in the transactional net promoter score from customers who use Jessica, and better first call resolution solving the issue the first time.
Those are solid improvements. Definitely seems like both Amdocs and RBC are finding real value in these smarter, specialized AI agents.
Absolutely. It's a clear step up from basic chatbots towards AI that genuinely understands complex domains and offers more effective help.
Now, all this clever agentic AI needs serious horsepower, right? A solid foundation. Let's touch on the infrastructure needed based on that Nvidia presentation.
Right. The NVIDIA session really hammered home how AI demands are changing. These newer models, especially the ones that do complex reasoning like the agents we've discussed, need way more compute power than older AI doing simpler tasks.
Mhm.
And also, this need for test time scaling, handling lots of users asking complex things all at once, just adds to the need for more powerful infrastructure.
So your standard server setup just won't cut it for enterprise-level agentic AI.
Probably not at scale, no. They laid out why investing in proper AI infrastructure pays off. Better use of the hardware you have boosts developer productivity, allows for centralized development, lowers the total cost over time, speeds up getting value back, and helps build up that crucial in-house AI expertise.
They mentioned the AI factory concept. What's that?
Yeah, the AI factory is their framework for the whole AI lifecycle.
No.
4 stages: data prep, train at scale, optimize and test, and deploy at scale. Get the data ready, train the big models, fine-tune and test them, then roll them out.
Makes sense.
And they stress the need for an AI center of excellence, the right people, processes, and platform working together.
And the hardware to power this factory. They talked about the DGX Super POD.
Exactly. The DGX Super POD, now with their latest Blackwell Ultra chips, is positioned as this ready-made AI supercomputer for enterprises building these AI factories. Massive power, fast memory, built to scale for the toughest AI jobs.
Managing something that powerful sounds like a job in itself. Is that where NVIDIA Mission Control fits in?
Correct. Mission Control is their software for managing this AI factory infrastructure. It gives you visibility into what's happening, telemetry. It manages workloads, helps with testing and diagnostics, has autonomous recovery if something goes wrong, and tools for setting up and managing clusters efficiently. The aim is to make managing the complexity easier so the AI teams can focus on innovation.
And this kind of heavy-duty infrastructure is what enables the agentic AI we've been talking about.
Absolutely. You need that kind of processing power from systems like the Super POD and the management smarts of Mission Control to train the huge models behind these agents, run those complex workflows reliably, and handle lots of users interacting with them in real time.
Okay, last piece then, DDN's data intelligence platform. Sounds like handling the data efficiently is also super critical for AI success.
Totally. DutyEnd's platform is designed to speed up NVIDIA AI enterprise, focusing on that whole data journey prep, training, building agents with tools like Nvidia Nemo and NIM, they highlighted Nemo Retriever specifically.
Email retriever, what does that do?
It's for advanced data extraction, handling multiple types of data, text, images, tables from different documents, helps the AI systems find and understand information much faster and more accurately. They reported big improvements in speed and accuracy with it.
The Nemo retriever helps these AI agents quickly find the right information from potentially vast amounts of data.
Precisely. It's really important for techniques like RAG retrieval augmented generation. That's where the AI fetches relevant facts from a knowledge base before generating its answer, making the response much more grounded and accurate.
Ah, right.
DDN also mentioned that Nemo Retriever helps make data storage more efficient, reducing the space needed for the vector embeddings these systems use to represent and compare information.
Sounds like a crucial piece for making these knowledge-hungry AI agents work well in the real world.
Definitely. Smart data management and fast, accurate retrieval are fundamental for building effective, scalable agentic AI.
Wow, okay. We have covered a ton of ground on agentic AI.
Oh.
Let's try and wrap up with the main takeaways.
Yeah, I think the big picture is agentic AI isn't just theory anymore. It's becoming practical, showing up in diverse areas: retail, healthcare, telecoms, finance.
We saw that real-time analysis at the edge in retail, enabling personalization but with a focus on privacy.
Right. And in healthcare, things like AutoML, making AI development easier and faster for specialized diagnostics.
And then those domain expert digital employees in customer service, aiming for more efficiency and better interactions.
And none of it happens without that solid AI infrastructure and strategic thinking about how to build and deploy these things at scale.
For me, the real aha moment is just seeing this tangible progress. AI that doesn't just wait for instructions, but
Yeah.
can understand, interact, and act more autonomously to solve actual problems and hopefully improve human experiences.
Exactly. It's shifting from passive tool to proactive partner in a way.
So maybe a final thought for everyone listening. As these AI agents get smarter and woven more deeply into our work and lives, what new possibilities really excite you? But also, what new responsibilities and maybe ethical questions do we need to think about as we build this future? Lots to consider there.
Absolutely. The potential is immense, but so is the need for careful, responsible development.
Indeed. Well, thanks for joining us on this deep dive into the world of agentic AI.